Hi class, in this lecture here I just want to talk really briefly about the graphs of polar equations. I just want to introduce you to basically what they're going to look like, show you how one very quick example of doing it by hand, and then I'm going to show you how to use technology actually to find them very easily. Okay, so here's what we're going to do. We're going to understand what the graphs of polar equations look like, and then at the end what I'm going to do is I'm going to graph these polar equations using this online tool here. So basically, when you click on the link, you're going to load up this website here. It's going to load up with all this Desmos website here. It's going to load up all these different equations in it here. What I'm going to do is I'm just going to clear all these equations out. And you're going to see how very quickly this little graph sketch the graph for you. Okay. All right. So to help us graph, what we're going to do is we're going to use polar grids to graph. And you can kind of see in here they had the polar grids. You know, this is radius 1, and then I can add another one. And so on. And I can add another one. And this is just these grids that I've been talking about here. All right, and so when I showed you how to graph these polar coordinates here in the previous lecture, you saw this is what I did. I sketched these polar grids. I drew a circle with a radius 1, a radius 2, and radius 3. Okay, so polar equation whose variables are r and theta. Okay, and so the graph of polar equation is a set of all points whose polar coordinates satisfy that equation. So we use these polar grids, like I said, like the one in this figure here, to help us graph these polar equations. Now, the two most common ones, or the ones that are the easiest ones, are graphs of this form. R is equal to a times cosine of theta, and r is equal to a times sine of theta. And this is for a is greater than 0. And when you have anything in this form, okay, these forms here, right, these are just circles, okay? Anything that looks like this or this, okay, just are circles. Okay? And so the differences is where they're centered when you do this. All right, so anyways, this is what the circle of r is equal to a times cosine of theta looks like. All right, looks like a circle here. And this is what the equation, or this is what the graph of the equation r is equal to a times sine of theta looks like. And so let me just walk you through how you would do this by hand. And then I'm going to show you, this Desmos here. All right, so let's sketch the graph of this. R is equal to 4 times sine of theta, okay, with theta in radians here. All right, so what you would do is you use multiples of pi over 6 from 0 to pi to generate coordinates for this points, okay, just so you can plot points r comma theta. All right, so I'm going to construct a partial table of coordinates here using multiples of pi over 6, and then we're going to plot the points, and then we're going to join them with smooth curves. And so basically what you're going to do is, I already have them here, is you pick your theta. Okay, so I did 0, pi over 6, this is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and pi, and I just simplified it. And what you would do is you plug it in for theta into sine, and you would get r. Okay, and then remember your points are r comma theta. So you can see here I have the corresponding points. And then when you sketch this, this is just what would happen, all right? So you would get this circle here, and it would be centered at 0 comma 2. And let me show you, verify this in Desmos here. Okay, so I want to sketch the graph of 4 times sine of theta. So you would go r is equal to 4, and then you type in sine, parentheses. And then to put in theta, you'd have to spell it out like that. And look, you can see right here, we got it. And if I just remove all these circles before, you can see this is what 4 times sine of theta looks like. Boom, we got it. And you can verify this by switching into rectangular form is totally fine. All right. So like, just to go back, what you can do that's really great is just to see this by hand. Okay. So like if I asked you to sketch real quickly, r is equal to 2 times cosine of theta. Okay. We know right off the bat it would just look like this. Here's 1, 2. It would just really briefly look like that. If I asked you to sketch r is equal to 5 times sine of theta, you could just say, okay, I know it's a circle here, and it's going to look like this. and it's going to go up to 5. It would just real easily look like that. All right. There are other types that I'm not going to ask you necessarily to graph this, but I want you to be aware of what they look like. Okay? So there are other common ones here. All right? There's what's called a lemicon. So graphs of this. R is equal to A plus B times sine of theta. R is equal to A minus B times sine of theta. R is equal to A plus B times sine of theta. And R is equal to, a little bit of a typo here. Sorry. Cosine of theta. A little bit of a typo. And A is equal to A minus B cosine of theta. And this is for A and B greater than 0. These things are called lemicons. And you would think, you know, if you're adding an A to it or something, it would just like shift the graph up or down. That's not necessarily what happens here, okay? And so the ratio, when you take the A divided by B, determines the lemicon shape. And you can see here, like, we have an inner loop if A is less than B, or excuse me, we have an inner loop if A divided by B is less than 1. You can see we have this heart-shaped if A divided by B is equal to 1. And so on. You can see these different ones, and you can experiment with this website here, like I wanted to show you. Okay, so you could go R is equal to 2 plus, you know, and then we'll do 3 times cosine of theta, and you can see, you know, you get this inner loop here. Okay, and this is because A divided by B is less than 1 here. All right. So you can fool around with that on your own. Then you can see here, this is what 1 plus cosine of theta would look like. All right. And there's other things called rose curves. And so we have graphs of R is equal to A times sine of n theta. So this is when something is inside the functions, or another one is R is equal to A times cosine of n theta. Okay. These are called rose curves. So if n, okay, is even, the rose has 2 times n petals, and if the rose is r, excuse me, if n is odd, all right, then the rose just has n petals. And you can see here different graphs, you know, put in here. And like, for example, if we were to sketch this one, r is equal to 3 times cosine of theta. Here, n is equal to 2, which is even. So it has 2 times 2, which is 4 petals, which is what you see here. And if you want to verify that by graphing with Desmos calculator here, R is equal to 3 times cosine of 2 theta. You can see that's exactly what you get here. All right, then the last type is what are called Lemnos gates. So the group of R squared is equal to A squared times sine of 2A, and then R squared is equal to A squared times cosine of, 2 theta, cosine of 2 theta here. These are called Lemnos gates. And these are just what their graphs look like here. Okay, they're just basically symmetric with the pole. Okay, and so I just wanted you to be mindful of these polar coordinates. I'm not gonna spend or polar equations, what the graphs look like. I'm not gonna spend a lot of time necessarily asking you to work with these, but they're gonna come up, especially if you go on and take calculus 3. You spend a lot of time working with things in polar coordinates. So just be mindful of what these graphs look like. Okay. And to use this Desmos here, if you're going to ask to, you know, just to want to get a quick look of what these graphs look like. All right, class. I know this was just a real incredibly brief introduction to this, you know. But if you have any questions, please let me know.